Okay, so, like I said, we've already done normal distribution. Here we go. So we've done normal distributions. We've done general normal distributions and we've done standard normal distributions. What's the difference? What's the difference between a general normal distribution and a standard normal distribution? What? What is the one major difference between a general normal distribution and a standard normal distribution? The standard has a not a mean of 1, a standard deviation of 1, but its mean is what? 0. Okay. So in a general normal distribution, it has just whatever is the mean and whatever is the standard deviation. The standard normal distribution has a mean of 0 and a standard deviation of 1. So standard normal distribution, which X is normally distributed with a mean of 0 and a standard deviation of 1. Not X is 0, mean is 0. Your mean is 0 and your standard deviation is 1. Okay? So, that's our standard. Now, what we've been doing is what? What have we done with this? What are those? But what is it? When we get that value back, what is that value? Probability. It's the probability of selecting or getting that situation. Okay, so when we're doing it, we've been dealing with probability. That's our result. What we're going to do today is we're going to go backwards. We've been result probability given. We've been given a mean, standard deviation, and some X value. Okay? So we've been given these 3 things, we're coming back to the probability. What we're going to do today is the reverse. All right? We're going to be looking for the result of an X value. Okay? And we're going to still be given the mean, the standard deviation, but now we're going to be given the probability. Right? So these, what we've been doing are the what? When we go into our calculator with our bars, which CDMs? Which one? The normal distribution CDF. Okay? Now what we're going to use is the next one below that is the inverse norm. Okay? We're going to reverse it. It's not any more difficult. It's almost the same calculator steps. So if you look at the paper that I gave you, it says the first one. If we have some random variable x that is normally distributed with standard deviation, a mean of 1 and a standard deviation of 1, it says find A, given that the probability of x is less than or equal to A is 0.88. So you see now, instead of finding the probability, this is what we've been trying to find before. By going through that process by second, bars, CDF, putting in the lower bound, putting in the upper bound, putting in the mean, putting in the standard deviation, coming up with the probability. Now when we go to our calculator, we're still going to do the same thing. So get your calculators out. And so the yours is going to be the same way. Yours is gonna be the same one, it's just gonna be the next one down in the inverse.
Then where I asked short area, that's those are the.
Yes, because remember, the area under the curve, all the area under the curve is equal to 1, probability is always equal to 1, so we can use those interchangeably. Now we're looking at this. Now we're looking at a probability or the area under the curve of 0.88, okay? So when we go second bars and we go skip the normal PDF, skip the normal CDF, we go inverse normal. That's number 3 now, it's the third one down. Now the 3 things that we have to put in are, so when we go inverse norm, the 3 things are the area, the mean, and the standard deviation. Okay? Well, no different than over here, we have the mean and the standard deviation, except we put in, we had the lower bound, we had the upper bound, we had the mean, and we had the standard deviation. We had to put the boundaries in this. Now we're working backwards. We've already got the boundaries. We've already got where this thing lies. We've already got the area under the curve. This part. We still need the mean and we still need the standard deviation. So for this problem, what's our area? 0.88. What's our mean? 0. What's our standard deviation? 1. It's a normal distribution. So, it's a standard norm. So put those things in. And what do we get back? 1.17. 1.175 or 1.174. So 1.1749. And yes, 1.17 to 3 significant figures because we need to really start working and getting comfortable with those 3 sig figs. Now, what is that value? That is that A value, that is that X value, that is the part that's going to give us that thing. Now, as far as in this, remember this graph, where is that? Well, what do we know? So it's a standard normal distribution. The mean is 0. So we know we're looking right here is 0. What are the standard deviations? 1. So this is 1, that's 2, that's 3, that's -1, that's -2, that's -3. Quick, easy sketch. Not accurate, but it's a sketch. Okay? Now, we're saying, okay, we found the X value. We found that A value to be 1.17. Well, where's 1.17? A little bit above 1. Here's 1.5, here's 1.25, so 1.17 somewhere in there. Well, if I were to shade this, there is my 0.88. That's the probability. That's the part that we looked at. That's the 0.88. So now, this guy, where that thing is that an upper bound or a lower bound? That would be the upper bound. So in one way, what we've just done, we're looking and making a connection back to this. We have found out this upper bound. What's our lower bound? Negative infinity. So this is that 1.17. So we found the place on our x-axis where that boundary would be. So before we had the boundaries, the mean and the standard deviation, and we found the probability. Now we're finding the probability and we're given the mean and the standard deviations. Now, what was that one thing? I'm hoping that you remember this. This is where the one thing that I told you, your calculator does something special. Which way does your calculator always calculate? The left. This is where this matters. Okay, because depending on which way this side is flipped, depends on whether that y bound is negative infinity or it's positive infinity. Or whether we have it at 2 spots. Okay, so we are going to have. What's up, Reg? You can ask Mom, I can't write that. Forgot his computer. Okay. All right, so back to this. Now, we found that 1.17. Now, this is that boundary, this is that thing. They're calculating to the left. How do I know that it goes to the left? Last thing. Okay? All right? So now, when we look at the other ones, we're going to look at this, and we're going to have to determine which way this thing is. Because now, remember the whole area under the curve? How much is that equal? 1. So if we want the parts to the right, what are we going to have to do? 1 minus. Okay? If we're okay for everything to the left of the boundary, then we just keep it. But if we want the stuff to the right, we're going to have to do 1 minus. Okay? All right. So, like number 2. What's different?
When it says find the value of A, that is just 1.17.
That's just at 1.17. So, in the answer for this problem, that is the answer, at 1.17. Okay? Now, number 2 is slightly different. Number 2, sorry, I can't remember it. Because again, if we're looking at a standard normal distribution, find the value for B such that probability of X greater than or equal to B is 0.65. What's the difference between number 1 and number 2? Right. That one is the less than, which means we're going to the left. This one is greater than, which means we're going which way? So our shading is going to the right, right? So this one's a case where we've got to do 1 minus. And what do I do? 1 minus what?
The area.
1 minus the area. What's the area? 0.65. So 1 minus 0.65 gives me what? That's my new area that I use. Because in this case, what I am going to be looking at, is, okay, the probability that I'm looking at is 0.65, so it's going to be there, so this guy is going to be going this way. My calculator doesn't calculate to the right, it calculates to the left. This is the area that I need for my calculator. Okay, so that's the part that I use my.
Until you get to negative,
I don't get a negative.
Negative.
I might get a negative value, but I can't get a negative area. Wait, you're asking for a negative for the answer for this? I don't know. Let's do it. Do you? I don't know. Okay, so second inverse, our area is 0.35. Now, how would I shouldn't have said I don't know. How would I know? How can you look at this and tell whether it's going to be a positive or whether it's going to be negative?
Because your answer is located in the negative side of the.
How do you know it's over there?
Because if you already give us something that's greater than, it's obviously going to be less.
Ah, what if it's over here?
And you have to look at the number that you're using.
How do I know that?
Because the area is less than 0.5.
Exactly. Because we know from either side of that axis of symmetry, either side of that axis of symmetry is half of the whole thing. Well, half of one is half. So if I'm looking at if I look at my mean, from my mean to the right of my mean, or I guess to the right of my mean, is 1/2. To the left of my mean is 1/2. Here, I'm looking at 0.65. So I'm really only looking at 0.35 for the area that I'm putting in. Well, 0.35 is going to be to the left of my mean. Well, if this is a standard, my mean is at 0, what values are to the left of 0? Negative. Okay? So then, if I get a value that is greater than 0, okay? Greater than 0, area that is greater than 1/2, my x values are going to be what? Greater, positive, yes. So there is a very quick and easy way. It doesn't tell us whether it's accurate, whether it's right, or whether it's wrong. But if I know it's supposed to be negative and I come on to a positive, I know I did something wrong, or vice versa. If I know it's supposed to be positive and I come out with a negative, I know I did something wrong. So it's a very, very, very good idea for these inverse norms to give a quick little sketch of what you're looking at, right? It doesn't give you a check to say, yes, this is right, good job. But it does give you that quick check, positive, negative.
So the calculator will always give your answer on the left.
Your calculator always calculates to the left side on this inverse norm of whatever value. Okay, so it deals, in other words, it deals with the area up to the boundary from the left. Put it that way. All right? And in this case, we wanted the area, we were given the area to the right of the boundary. So we had to put this area in the calculator to give us this boundary. All right? All right. Number 3. Is that any different than number 1 or number 2? No. Okay. Just be careful with where you put it in. So put those in and tell me what you get for number 3. What'd you get?
4.80.
4.80? For which one? For the third one?
Yeah.
Okay.
I have 5.19.
All right, so we get inverse norm. What's our area?
You guys are like
0.87, but it's 0.63.
0.63. Why is 0.63? It gives us 0.37.
It's greater than, so we subtract.
Which greater, so we go 0.67. What's our mean?
It's 5.
This case, the mean is 5. This is a general, it's not a normal. And then what's our standard deviation? 0.6.
5.1.
5.1.
1, 2.
5.12, 5.12?
5.9. 5.2. No, because you said, the area is 0.67 and 0.63.
Yeah, it's point.
Oh, 0.63. Sorry.
Yeah, so it's 5.1.
Inverse norm, 0. Subtracted. 5.1991. So 5.1991 is what? 5.12. 5.199, 5.12. 5.2, so 5.12, 5.2.
But no, 5.12. Okay, yeah, it's 5.1.
5.199.
So
So it's 5.11.
Well, 5.199, well, 1, 2, 3, so there's 3. This guy dictates what happens, so this thing, the 3 significant figures, this is 5 or more, so it makes this one go up, but when this one goes up, puts 1 there, so it's 5.20. Okay. So be careful. Tricky one for number 4. All right, we'll put this one up on the screen. See if you can get number 4 while I'm putting it up on the screen. Look. So we've got number 1, number 2, number 3. Looking at number 4. What's different about number 4? We have 2. Okay, we have 2 values. We have a D and an E. And these are not normal distributions, these are general, these are not standard distributions, these are general. So be careful about what you put in for your mu and what you put in for your sigma. Anybody got it? Find D and E yet?
Did you just do it like you did 1?
True.
Oh, okay, but, D is 14.2.
D is 14.2, she said.
And E, I'm not sure.
It's 18.3.
18.3. So we got 2 conjectures. 14.2, 18.3. See if you can verify or discount these. So we have 2 votes for 14.2 for D. 3, all right, so we're pretty confident that D is 14.2. All right? So let's see, X is normally distributed, mean of 17, standard deviation of 2.2, so we're looking for that. So we would have our inverse norm, our area for D is 0.1, and we're looking less than, so we're going to the left, so we don't have to subtract anything. So we use the 0.1. Ah.
What is D SAT?
14.18, so 14.2.
I got E is.
So in other words, what is happening here? Our mean, that's 17. Standard deviation of 2.2. So we're looking at a probability of 0.1, so that's down here. All right, so there's D. And then E is 0.72, so that's somewhere up here. There's E. Let's see, I went this way, let's go this way. So what happens here? So what's the difference? The first couple that we've done, how many boundaries were we looking at? 1, but the second one was what? Here's one boundary that we found, what's the other boundary? Negative infinity. The other ones that we found were greater than, so we had one boundary and positive infinity. Well, it's just like the other times. Well, when we started back with the normal distributions, we had either a lower bound of negative infinity, and we had an upper bound, or we had a lower bound of some number and an upper bound of infinity. And then the third type that we did is we had a lower bound number and an upper bound number. Well, this is what this is. We have a lower bound, D, and an upper bound, E. So now we have this lower bound of D, which we've said is 14.2, and we're verified on that. Now we have to find E. So right away, we know, what do you know about E? Greater than 17, okay? Because we have a, oh, I didn't write it up here, probability of 0.72. Well, 0.72 is greater than 1/2, so I know it's on the right side of my mean, so I know it's greater than 17. What is it?
19,
How did you get that?
0. I added the areas together
Why?
because it's the whole area under that, so it includes the 0.1 as well.
So what is the area that we're looking
0.82.
at? 0.82. And when I put in that 0.82, so we go second bars, inverse norm, area is 0.82. Mu is still 17, standard deviation is still 2.2. 19.0.
So did you just add those 0.1 to the 0.
This is why. Because we're looking at the probability between these. So actually, when I shaded this, I shouldn't have shaded over here. So this probability that we're given is 0.72. This probability that we're given is 0.1. So to find the whole probability, to find that boundary for D, I've got to take those and I've got to add those two, and that's why we get the 0.82. So then we get, sorry, I didn't, somebody said the answer and I don't know what it was. 19.01, but 3 significant figures. How many significant figures is that? It's 4. So 19.0 or just 19. Okay. All right. Not too difficult. What's that? Because this one is given to us that it's the area, the probability, the area between D and E is 0.72. Well, our calculator doesn't calculate that part. Remember, it calculates everything to the left of that. Well, everything to the left of that is the 0.72 and this 0.1. So that's why I've got to put these two together to get that 0.82 from my area. And then we use that area. The area is 0.82. The mu is 17 still. And then the sigma is still then at 2.2. And if we use those three values, then we get the value for E, which is that 19.01 or 19, which is significant figure. Fair enough? Like I said, it's not much more difficult than the normal distribution, which we were working in front of you. All right, so the next couple, we'll do the next one together. Word problems, love them. What's mine? All right. In some certain year, Bernard estimates that 5% of his lambs, he's a lamb farmer, have not reached the required mass for market. The mean mass for the lambs this year is 38 kg, and the standard deviation is 2.85 kg. What is the minimum mass requirement for the lambs to be sent to market this year? Better find it.
Why is he selling these?
Because he doesn't sell goats.
Then we should have, but I love it.
Bernard. I like that name, Bernard. I was gonna put one of your guys' names in there, but I didn't think anybody wanted to be a lamb farmer. Yeah, I should put you in You don't have an area. Okay. Okay, so first problem. Ladies and gentlemen, first problem. The problem was that we're not given an area.
What?
But we are. 5%. Remember that 5% percentage we can convert to probability. Probability converts back into area. So, in other words, all we have to do is take that percent and do what with it? Divide by 100 or convert it to a decimal. 5% as a decimal is what? 0.05. So, our probability is 0.05, which means that we have an area of 0.05. From there, do we have our mean?
Yeah.
What's the mean? 38. And the standard deviation is 2.85. So like it's your bad. So I got to vote for 33.3. Anybody else?
Yeah, I second it.
Second that one, so it's 33.3. So 33.3 kgs. All right? I don't know, is that a big lamb? I have no idea. Not a lamb herder. Sorry? That's a big lamb, 65 kg. The mean is 38. That's a big lamb. Okay.
It's a lamb, oh my gosh!
You're the lamb farmer. Okay, so we'll try one more together and then we'll go on to the standardized. All right, so I'm gonna throw the teachers of AISD out. All right, so the masses of the teachers here at AISD are normally distributed with a mean of 65 kg and a standard deviation of 9.3 kg. What is the probability that I have a mass of more than 75 kg? Well, that one is the probability. Yeah, don't get me. Send that. Right, put it on the wall. That's fun. I'll put it right there with
My favorite is
that.
the
Fun
parallel
guys.
line. My parents can be scared of me. I do this when mom watches.
Do you know how many people look at that and they're like, I don't get it.
Why do you know?
No, I said, but my parents used to have to go parallel because once upon a time, they scared of me. Yeah, that's.
Over their head and over their feet.
But they got it, they just don't want to laugh because we feel good, they scared of me.
Nobody wants to laugh at math jokes.
Oh, so it was positive.
Which, by the way, they keep falling. Apparently that one is heavier than all my other ones.
Sorry?
I said apparently that is heavier than all my other ones. It keeps falling.
Oh.
Okay, so the masses of the teachers are normally distributed via 65 and standard deviation 9.3. What is the probability that Mr. Easter has a mass more than 75 kg? So, what kind of problem is this first one?
It's a regular.
It's a regular normal distribution. Okay, so we're looking for the probability. So it's not an inverse norm, so the probability that I have a mass more than 75. So we go back, did I give you a lower bound, upper bound, or what did we have? Lower bound is 75. So we work our way through that, standard distribution, CDF, lower bound 75, upper bound, what's my upper bound?
You don't more than 75 kg.
Negative infinity.
Upper bound can't be negative. 65, standard deviation of 9.3. And she says that apparently I'm not more than 75 kg. Why? 0.14. 141. 3 things. Okay. So, not very likely that I'm greater than this. I can say that, very stealth. You can tell that these are definitely made up. Okay? Well now, 80% of the teachers have a mass less than m kg. Determine the value of m. So this one, good. Got it? Okay. So this one, part B, are we doing a normal or an inverse norm? Inverse norm. Because we're given the probability, we're given that area, we're trying to find a specific point. What's the area? 0.8. So what is n? 72.8. Okay. All right. All right, your homework. Your homework is to do the tomato farmer, Mr. Ramirez, because that's the last problem on there. Or did I put problems on the back? I think that was the only one. I was gonna say that was the only one. Tomato farmer. A lot of farmers, they're gonna farm the food. Lamb herder, farmer, tomato farmer. No, trees grow every day. Right. Guess what? Bamboo grows up to 30 centimeters per 24 hours, so I don't think we're hurting. A lot of Amazon. Yeah, but 7 football fields worth of grass is planted Yes, okay. Ladies and gentlemen, what I want you to do is once you take a second, once you get refocused, take whatever you need to do because we're going to slightly change gears. So we're done with the normal distributions, we're done with inverse normal distributions. Excuse me. What we're going to do now is we're going to take and we're going to take our general normal distributions and we're going to standardize them. Okay? Out of the 3 processes that we are going to do, this is the most complicated. It's not super complicated. All right? So what we are going to do is we're going to take a value, we're going to take it from a general, we're going to standardize it, we're going to put it into a normal, a standardized normal. The crazy thing about this though, or the most difficult thing about this, is what you will see with your IB is it'll go both ways. They'll give you a standardized value. You have to unstandardize it. You will give an unstandardized value, and you'll have to standardize it. They use the same formula, the same process. Okay? This is the trickiest part about everything, because you have to determine which way you're going and put the things in the same place. The easy part is, it's the same formula. Okay? It's the same formula, it just depends on which one you're gonna solve for. Alright. So, I'll put this up here, I guess. Standardizing a normal distribution. Any normal distribution can be standardized. Meaning, we can take it, any of these, I wish I erased all of them. The last one that we dealt with weights was, well, I'll just take this one. So we can take this is problem number 3 that we did on the last page. We can take this and we can change it from just a normal, just a general normal, to a standard normal. Well, the standard normal means that the mean is what? 0, and the standard deviation is 1. So I can take this and I can change it, I can transform it into this. All right, but then it's not going to be my x, it's what's called z. Okay? All right? Now, how many of you guys are in psychology? I think a couple of you were in psychology, which is my other class. You guys talk about z-scores?
Oh, yeah, I know they are. Isn't that in the man, women test? Or in the,
And a lot of those personality tests and
it's almost like the, it's almost just kind of like the Kaiser.
it is a statistic, yes. And it helps standardize and it helps level the playing field. Remember, you guys all have taken or are going to take, or most of you anyway, taking your SAT. I think they give you anymore, I gotta remember which one is it, the SAT, ACT, maybe both. They give you a mean score, and then they give you, I think they might even give you a Z-score. I'm not sure. And that means they standardize all the scores, they put them into this process, they crank them all out, they change them all, and then they normalize everything, okay? And then they standardize all these normals, right? And what you get back is that you know where you're at, right? All right, so if we're looking at this thing, we're gonna take this x, which is normally distributed with a mean of 2 and a standard deviation of 0.5. Well, if we were gonna graph that, if we were gonna sketch a graph of that, what would that look like?
0.5, 1, -0.5.
So put that into a graphic, in case you didn't quite get that. The mean is 2. 1 standard deviation above would be what? Not 0.5.
Oh, it's 2.5.
2.5. 2 standard deviations above would be what? 3. 3 standard deviations above. 3.5. 1 standard deviation below. 1.5. 2 standard deviations below. 1, and then 3 standard deviations below. 0.5. So there's the sketch of this. All right? Rough sketch, but that's what that is. We are going to take this and we are going to convert that into a standard. But if you look at it, like we said, the curve is centered around a mean of what? 2. Okay? Which lies to the right of what? 2 on a number line. 2 lies to the right of what? To the right of 1, to the right of?
3.
Not 3.
1.5.
Okay. What's another number that helps us out with a normal distribution, a standard normal distribution?
0.
0.
Yeah.
Why is 0 important? Where is 0 with our standard normal distribution? 0 is the mean. It's in the middle. That's where we want it to be. Because we want this thing, we want this now to be 0. Okay, because that's where our standard normal distribution mean is. Okay? Well, now, if that's the case, if I want the mean to be 0, what did I do with all of my values? What do I have? Shifted which way?
To the right.
Shifted it to the
Left.
to the left. How many? 2. So now, 1 standard deviation above would be what?
0.5.
0.5.
1.
1. 1.5. Now it's going to be negative 0.5, negative 1, negative 1.5. But it's not quite standardized. Why is it not quite standardized? Well, it's not 2 because the standard deviation, it's not the standard deviation that we want. This has a standard deviation. It has a mean of 0, but it has a standard deviation of what? 0.5. It says a standard deviation of 0.5. Is a standard normal distribution doesn't have a standard deviation of 0.5. No, it has a standard deviation of 1. So it's double. Okay? So what I have to do is I have to go through this calculation, and what I've got to do is I've got to double all of these values. Okay? So that's this part. In other words, we just answered these. We can make this curve a standard deviation needed. What's the standard deviation needed? 1. How do we go from 0.5 to 1? We multiply by 2. Or we divide all of the x values in our distribution. If we divide all of our x values by this standard deviation. In this case, our standard deviation was 0.5. It's not always going to be 0.5. So what I would have to do is take all of these and divide all of those x values by the standard deviation. In this case, it was 0.5, right? It's not always 0.5, all right? So when we do all of this, this is standardizing the normal. And when we standardize the normal, we follow this. And it's a little difficult to see, didn't come out perfect, but this is your z-score. Z is equal to any of those x values minus the mean, all divided by the standard deviation. That's the formula that you need. Right? Yes.
So the x values for the new curve?
So these z are the x values for my new curve. So when we get this, these are the ones that we will have a standard 1, 2, 3, negative 1, negative 2, negative 3. So these new z-scores, when we figure these new z-scores out, they will correspond to these.
So those are the x values that we're going to use for.
So, in other words, okay, the x value of 2 has a z value of what? 0. All right? Now, if I look at an x value of 3.5, take the same example, I look at an x value of 3.5. What is the z value when we have that? How do we get it? Well, we follow our formula. We take the z value is equal to the x value minus the mean divided by the sigma. So our z value is the x value, 3.5, minus the mean, what's our mean? 2, divided by our sigma, which is 0.5. So 3.5 minus 2, what's 3.5 minus 2? 1.5 divided by 0.5, it is 3. Is that right? Well, 3.5, that was 1, 2, 3 standard deviations above. That would correspond to 3. Yes. Okay. Well, real quick, 2.5 has a z-score of what?
2.
1. 3 has a z-score of 2. 0.5 has a z-score of what? -3. So in other words, all of the standard deviation values, all of the single standard deviation values, 0.5 has a z-score of -3, 1 has a z-score of -2, 1.5 has a z-score of -1, 2 has a z-score of 0, 2.5, z-score 1, 3, z-score 2, 3.5, z-score 3. Okay, in this case. Well now, 1.75 isn't on any of my standard deviations. Well, that doesn't change anything. So if I want to find 1.75, all I do is come over here, and instead of taking 3, I take 1.75. Well now, what's 1.75 minus 2 divided by 0.5? -0.5. Does that sound right? Should we come out with a negative? Well, 1.75. 1.75 is to the left or the right of 2? Left. So then that means that our z-score is going to be to the left or the right of 0? Left. What numbers are to the left of 0? Negative. So it does correspond. We get a negative number. We should have. I'm sorry. Right? So, which tells us 1.75 is, or has a z-score of -0.5, which is to the left of 0. Okay? Or, in terms of standard deviations, it is -1/2 standard deviations below the mean. Oh, this one's difficult. See if we can figure this one out. Now, what's different? Let me start you off. This one, what are we dealing with? We start with probability. See if you can think about that one. See if you can figure that one out. Yep. Yep.
For the 1x equals 1.75, could you give the same you wanna use the formula, would you use the same standard deviation to enter them?
I think I missed something. Do we do what now?
So like if for x equals 1.75 minus z, we would formula to use this.
Yeah, so same. Correct, so it doesn't correspond to any of the standard deviation, so that's why we have to do this to find out where it is.
What's different here? Have you figured it out? This problem is no different, well, starts off no different than the ones that we just did. It just takes it to the next step. So in order to find the probability, what do we have to have? We have to have the z value, we have to have a standard deviation, we have to have a mean, and we have to have, well, that z value, not just one, we gotta have two, because what do we need to calculate the probability? Bounds, lower bounds and upper bounds. Okay, so we need to change this 3.2. We need to standardize this, okay, to get a value. Determine whether this is the lower bound or upper bound. Well, this 3.2, is that the lower bound or upper bound? It's going to be less than or equal to 3.2, so it's going to be the upper bound. Then the lower bound is going to be negative infinity. Well, what's my mean going to be? Why 0? Because we're standardizing. What's my mean? I assume your mean, my standard deviation is 1. So now I change this, convert it to a z-score. So I'm going to find the z-score of 3.2.
So if it's 0.9.
But can you use the exact same numbers though? You use the 2 as the mean and the 0.5 as the number.
You will get the same thing.
You get the same answer.
Because if you calculate it.
Yeah, I did.
Okay, so right now, what do you find, without standardizing it, what do we get as a probability? 0.992. Okay, we should get the probability for the z-score to be exactly 0.992. Same thing. Okay, so we need a z-score for 3.2. Well, 3.2 minus 2 divided by 0.5. What's 3.2 minus 2 divided by 0.5? 2.4. Now, we go in, we set our lower bound to negative infinity, upper bound to 2.4, mean of 0, and standard deviation of 1, and what do we get as our probability? Same thing. Okay? Same thing. Right. Now, what does this open the door to? Okay. Now we can go backwards, because now I can give you a probability. In a standard normal, you have to convert that standard normal into an unstandardized normal to get the unstandardized x value. In other words, going completely backwards from the problem that we just did. We started with a non-standardized x value, standardized it, and got a probability. Now we should be able to take the probability from a standardized, get a z-score, use this guy to get the x value, and then we can find the original value. What two things do you need to do that?
The original mean and the original standard deviation. Okay, so be careful. That is the trickiest part of this whole process.
So what we do the index.
Right? So you've gotten all of these things. So you've got one problem down there, time taken to go through security checkpoints at an airport, and you've got Ramirez's tomato farming business. 2 problems. That's it.